This video is about trig ratios and some special angles that we need to commit to memory. So these angles include 0 degrees, 30, 45, 60 up to 90. Now we'll focus on these three: 30, 45 and 60 degrees. So now let's begin with an isosceles triangle for a right angled triangle. So an isosceles triangle is just a triangle where two sides and two angles are equal. So let's have a picture here. So assuming this triangle is an isosceles triangle, we can see that we have here this angle of 90 degrees. So the other two angles must be equal. So each angle will be equal to 45 degrees, so that if these three were to be added together can give us the value of 180. Now these two sides must be equal. So if these two sides must be equal, we will just let's assign numbers like let's say this is distance 1 and also this is distance 1 also. So what we are going to do is we need to find the hypotenuse. So this is our h, then we have this adjacent, and also we have this adjacent. So if we can use Pythagoras to find h, we'll say this is our a, b, c. The formula for Pythagoras is c squared is equal to a squared plus b squared. So c squared is equal to the value of a is 1 multiplied by 1 plus, then our b is also 1 times 1. C squared is equal to 1 times 1 is 1 plus 1 times 1 1. So c squared is equal to 2. If we take the square root on both sides, we can see that the value of 2 is equal to the square root of 2. So we are just going to leave it like this. So the hypotenuse is the root of 2. Now after we have these three distances, we can now go back to the three trig ratios denoted by the mnemonic SOHCAHTOA. So first we'll begin with finding the value of the sine. So from the in the SOHCAHTOA is sine theta is equal to opposite over adjacent. So now let's go back to our diagram. So we are going to choose any of these two angles. Since they are equal, we'll look at any of any it can work. So let's put this angle into consideration. If this is our angle of consideration, then we have the distance opposite here, then we have this adjacent and the hypotenuse. So we can now proceed by finding the sine. So sine of angle 45 is equal to, what's our opposite is 1 over hypotenuse is the root of 2. So this is our first special angle that you need to put in, you need to commit to memory. So sine 45 is equal to 1 over root 2. You can also prove this on the calculator. You can press sine 45, then it will give you 0 point something, then also try to, now 1 divided by root 2, you are going to get the same value. So sine 45 is equal to 1 over root 2. Let's look at the curve from the SOHCAHTOA. So that is cos theta is equal to adjacent divided by hypotenuse. So cos c, the angle is 45, is equal to the adjacent is 1 over the hypotenuse is root 2. So from these two special angles, we can see that sine 45 and cos 45 have the same value. So you can try to prove that on a calculator. You're going to get the same value. So the special angles that you need to have in mind are just these values. So you need to know that where there is sine 45, you substitute with 1 over root 2, and cos 45 1 over root 2 also. Now let's look at the TOA. The TOA, so that is tan theta is equal to opposite over adjacent. So tan 45 tan 45 is equal to 1 over 1, which is giving us 1. So tan 45 is equal to 1. Then there is another thing that you need to also know. We'll begin with the sign. So if we subtract 45 from 180, we get the value of 135. So sin 135 will be equal to sin 45. So this is also 1 over root 2. This is very important. So whenever you have a certain special angle, if you subtract that angle from 180, the remaining value is equal to the trig ratio of that angle. So let's look at cos 45. So we'll also say cos 135 is equal to, now for cos in the second quadrant, we need to have it's the negative root negative 1 over root 2. What of tan? So tan 135, since we are doing it with the same 45, tan 135 is equal to negative 1. So from these three, we can see that only sine is positive. Sine is positive in the first and the second quadrant, but for cos and tan, we need to add the negative sign. Okay, so now let's move on to the other triangle. Now for this triangle, we'll look at an equilateral triangle. So this is the kind of a triangle where all the three distances are equal. So let's say we have this triangle, and each distance is equal to 2. So if each distance is equal to 2, then each angle is equal to 60 degrees. Now here what we are going to do is we are going to draw a line from A perpendicular to BC, so that we form a right angled triangle inside. So we can draw this line perpendicular to BC. So we have each triangle here, we have formed two right angled triangle. Now what we are going to do is we need to just get one of these right angled triangles. So let's have this. Yeah, sorry with my drawings. So from we'll consider this is our A, B, and C. This is C. Let's call this D. So now we have this distance BC, which is equal to 2. So this line that we have drawn perpendicular is cutting this line BC into two equal parts. So from here up to here we have 1. Also here we have 1. So we have 1 here, 2. So we are going to find this distance AD. Now before we find the distance AD, let's also indicate the angles. So here we have this 60 degrees. Now the 60 degrees on A is divided into two equal angles. So here we need to have 30, and also we have 30. So we have 30 here. So under this point, we are looking at two special angles, the 30 and the 60 degrees. Okay, now let's first beginning by finding the third distance. So we use the same principle for Pythagoras theorem. So say A, B, C. So the formula, the general formula is C squared is equal to A squared plus B squared. But since we are solving for the value of A, we'll say A squared is equal to C squared minus B squared. So you subtract the B from C. So let's now find this A. So C is 2 squared minus our A is 1. So the squared, this is our hypotenuse, that's our C. So a squared is equal to 2 times 2 is 4 minus 1. A squared is equal to 4 minus 1 is 3. So introduce the square root on each side. So the value of A is equal to root 3. So here we have root 3. So now since we have all three distances, we are going to now find the three trig ratios. So SOHCAHTOA, from SOHCAHTOA. So we need to choose which angle are we going to begin with. So let's begin with angle 30. So this is our angle of consideration. So for 60 we can ignore it for now. So let's look at 30. So if we are looking at 30, so this is our opposite, adjacent, then hypotenuse, like this. Okay, so we begin with sine. So sine theta from the SO part is equal to opposite over hypotenuse. So sine, our angle is 30, is equal to, what is our distance opposite is 1 over the hypotenuse is 2. So sine 30 is 1 over 2, or we can just say it's half, or 0.5. Now let's look at let's subtract 30 from 180. So 180 minus 30 is equal to 150. So sine 150 is equal to also half. That's a pattern. And for sine, we said that sine is positive in the first and the second quadrant, so no need of introducing the negative sign. Let's move on to cos. So cos theta, cos is equal to adjacent over hypotenuse. So cos 30 is equal to adjacent. Adjacent is root 3. Hypotenuse is 2. So what of 180 minus 30 is 150. So what of cos 150? Cos 150 is equal to negative 3 over, root 3 over 2. Okay, let's move on to tan. Tan theta is equal to opposite over adjacent. So tan 30 is equal to opposite is 1 over the adjacent is root 3. What of tan 150? So tan 150 is equal to negative 1 over root 3. So we are done with the angle 30. So let's look at the same triangle, but let's look at the angle 60. So let me redraw. So this time let's put the 60 into consideration. So if this is our theta, then this distance is opposite, here adjacent, here hypotenuse. So we can now move on to finding the three trig ratios. So from the SOHCAHTOA, so let's begin with sine theta is equal to opposite over hypotenuse. So sine 60 is equal to the opposite is root 3 over the hypotenuse is 2. Then if we subtract 180 minus 60 is 120. So what is sine 120? Sine 120 is equal to root 3 over 2. Let's move on to cos. Cos theta is equal to opposite over hypotenuse, adjacent over hypotenuse. So cos 60 is equal to what is our adjacent is 1 over hypotenuse is 2. So cos 60 is half. So what is 180 minus 60? That is 120. So what is cos 120 is equal to negative half. Then let's look at now the tan. So tan theta is equal to opposite over adjacent. Tan 60 is equal to, the opposite is root 3 over the adjacent is 1. So tan 60 is equal to root 3. What of tan 120? This is negative root 3. Okay, so this is how some of these special angles were brought into consideration. So what we are going to do now, we need to summarize these special angles by writing them into a table. Okay, so we can now summarize the special angles with this table. So begin with the first one. Sine 0 is just 0. Sine 30 is 1 over 2, half. Then sine 45 is root 2 divided by 2. Sine 60 is root 3 divided by 2. Sine 90 is 1. Now for cos is like the reverse of this sine. So cos 0 is 1. Cos 30 is root 3 over 2. Cos 45 is root 2 over 2. Then cos 60 is half. Cos 90 is 0. Then for tan 0 is 0. Then tan 30 is root 3 over 3. Then tan 45 is 1. Then for tan 60 is root 3. Then for tan 90 is undefined. So you can use this table to memorize these special angles, or you need to find ways of how to come up, because there will be some questions where you are not allowed to use a calculator. You just have to memorize this. So make sure you commit this to memory. Now let's look at some of the examples where these special angles can be applied. Okay, so now the first example, the diagram below shows triangle ABC in which AB is equal to 18 centimeters, angle CAB equals 30 degrees, and ABC is equal to 90. Now the question is calculate the length of BC. So we can see that we only have one distance here, so we can't use Pythagoras theorem. So we are only remaining with now trigonometry. So let's now look at what we have here. So the angle theta is here, so this is our opposite. Then we have the adjacent and the hypotenuse there. So from there we are going to use one of the 3 trig ratios from the SOHCAHTOA. So we need to look at which trig ratio can be applied with the information given there. So let's look at first, what are we looking at? We are looking for BC. So BC is on where? Opposite. So we need to look at the trig ratio with opposite. So we can see that we only have SO and TOA. Car is disqualified. Then what else do we have? So we have hypotenuse. So we need a trig ratio where we have the H and O. So it is the SO. So let's find out the answer. So sine theta is equal to opposite over hypotenuse. Then sine, what is the angle? 30. And remember, no calculator, this is paper 1 mathematics. So sine 30 degrees is equal to, what's our opposite? Is the distance we are solving for. Then the hypotenuse is 18 centimeters. So over 1 we can cross multiply. 1 times BC is BC. Then here we have sine 30 is equal to, multiplied by 18. Now what is sine 30? So now we can now recall under the trig, the special angles, we said sine 30 is 1 over 2 is half. So where there is sine 30, we substitute with the half, so times 18. So now we can now find the answer. If we divide 2 here is 1, 2 here is 9. So 9 times 1, our distance BC is equal to 9 centimeters. Okay, let's look at another example. So example 2, it is given that triangle PQR below is right angled at R. QR is equal to 4 centimeters and tan QPR is equal to 4 centimeters. Now the question is find sine PQR. So the angle is the letter in between, so we are solving for this angle here. So now for us to find this angle, we need to identify the distance, the opposite, adjacent, and hypotenuse. So this is our opposite. Okay, let me use the green color. So this is our opposite, adjacent, and hypotenuse. Now let's look at the formula for the trig ratio for sine. So sine is given by theta is equal to opposite over hypotenuse. So from this formula, we need the distance for opposite for us to proceed by finding this sine, and for hypotenuse, and we can see that we don't have these two distances. So what are we going to do? And we only have this adjacent. Okay, so now let's go back to this part here. So we are told tan QPR is equal to 4 over 3. So let's write the formula for tan. So tan theta is equal to opposite over adjacent. Then from the given tan here, we can see that the letter under consideration is P. So for tan, we are given P. So this is where our P, angle P is. If this is where our angle P is, the 4 centimeters is our opposite. Then here we have adjacent, then hypotenuse. So what was the importance of tan 4 over 3? The importance of tan 4 over 3 will help us to find the two distances that are needed for us to find sine PQR. So let's go back to tan. So tan theta is equal to opposite over adjacent. So what this means is the denominator here, this number represents the opposite, then this one represents the adjacent. So if we use P as the angle in consideration, so the opposite is 4, we can see that we have the 4. Then the 3 indicates the adjacent if the angle P is under consideration. So this is our D adjacent. So we can now remove these since we have these. We can now proceed by finding the sine. So for us to find the sine, we need the hypotenuse. Now what are we going to have? Since we have the two distances, we are going to use now Pythagoras theorem. So like the formula, this is our A, B, C. So A or B can be anything, but the hypotenuse is always the longest distance. So the formula is C squared is equal to A squared plus B squared. So C squared is equal to A is 4 times 4 plus 3 times 3. So 4 times 4 is 16 plus 9. If we add these to give us 25, let's find the square root. So square root of 25 is 5. So the hypotenuse here, we can see that we have 5. So sine, now sine PQR, we can now find this. We have the all three distances is equal to the opposite is 3 over the hypotenuse is 5. So this is our final answer. Let's look at another example. So example 3, in the diagram below, BCD is a straight line. AB is equal to 12 centimeters, AC is equal to 20, and angle ABC is equal to 90 degrees. Find the value of cos ACD. So cos ACD, the angle is this one. This is our cos ACD. Now let's try to draw this line here. So we have this straight line B, C, D, then we have this line here. So this angle, this is our interior angle, then this is our exterior angle, and we know that a straight line adds up to 180. So I plus E, the interior angle plus the exterior angle, should add up to 180. So if we are able to find the angle, the inside angle, minus subtract it from 180, we can be able to find the exterior angle. Now what is the importance of this? So the importance of this is we can find the inside function, I mean the inside angle. This inside angle is between, yes, 0 up to 90 degrees. So it is in the first quadrant. So now for the outside angle is between 91 up to 180. So this one is in the second quadrant. Now since we are dealing with cos, for the first part here, the first angle, cos is positive. Then in the second quadrant, cos is negative. Remember we said that if we have like cos, we said cos 60 is equal to 0.5 or half 1/2. Now if we subtract this 60 from 180, we get cos 120 will give us negative 0.5. So what are we going to do? So what we are going to do is we are going to find the trig ratio, the inside for angle SCB, this one inside here. Then this inside is denoting the angle in the first quadrant. Then for us to find the angle in the second quadrant, we are just going to introduce the negative part. So my point is, if let's say we have an angle like this, if this angle here is 0.5, and if the question is what is the outside angle, as long as we are dealing with the cos, the outside angle is negative 0.5. So we just introduce the negative to the inside part. So let's put this angle as our angle of consideration. So let's find this one here. So if we look at this angle here, for us to find with cos, so this is our opposite, adjacent, and hypotenuse. So let's look at for cos. So the formula for cos is equal to cos theta is equal to adjacent over hypotenuse. So we can see that we need this adjacent distance for BC. Now since we have the two distances, we are going to apply now the Pythagoras theorem, where we say we have A, B, C, and the formula we said C squared is equal to A squared plus C B squared. Now since we are solving for B squared, so this is same as B squared is equal to C squared minus A squared. So B squared is equal to C squared is 20 times 20 minus our A is 12 times 12. So B squared is equal to 20 times 20 is 400 minus 144. So 400 minus 144 is 256. Then we find a square root. So the square root for 256 is 16. So the distance here is 16. So now we can look for cos ACB, the inside one. So cos is equal to The adjacent is 16 over the hypotenuse is 20. So this is the inside. Now what is the cos of ACD? The outside. So the outside, we just have to introduce the negative, so it's negative 16 over 20. So that is how you can find an answer for that. Now let's look at the last example. Okay, so now the last question, the diagram below shows triangle PQR in which PQ equals 12 centimeters, QR 10 centimeters, and angle PQR is equal to 150. Find, calculate the area of triangle PQR. So the formula is area is equal to half AB sine C. Now let's look at how do we deal with a non-right angle triangle. So this distance corresponding to angle Q, we are going to have this, then here we have small letter P, and here we have small letter R. Okay, so these two distances A and B denotes the two distances that are forming the angle. So in our case, our formula will be half P R sine Q. So this is area is equal to half. What's our P? The distance for P is this one. So 10 centimeters. For R is this one, 12 centimeters. Then sine this angle, so sine 150. Now this is we are not using a calculator. So what is sine 150? So what we are going to use to do is let's subtract 150 from 180. So 180 minus 150 is equal to 30. So what is sine 30? Sine 30 we said is half. Then if you remember, we said if sine 30 is half, also sine 150 is also half, because for sine in the first and the second quadrant, their sign is always positive. So sine 150 is half. So we can now do this. So 10 is same as 5 times 2. Then 12 is same as 6 times 2. Then sine 150 it's half. So what are we going to do? Let's cancel. So we'll cancel this, we'll cancel this, we'll cancel this, we'll cancel that number. So our final answer, area is equal to 1 times 5 is 5 times 6 is 30. Centimeter times centimeter, we have squared centimeter. So this is how we can look at some special angles that we need to commit to memory. And that's it for this video. Thanks for watching.